Okay, so this is the first drill. Number 1, just jot down the answer, 10% of 48 meters. Number 2, and I'll move along at a reasonable speed because I think you should be doing these reasonably quickly. 3/4 of £8.20. I'm hoping you're going to be able to do these in your head, but if you need to do a little scribbling at the side, that's fine. Certainly no calculators. Number 3. Algebra, of course, is going to rear its ugly head reasonably quickly in maths, and it's a very useful tool to engineers. Algebra involves this unknown x. 2x plus 3x equals what? Just jot down the answer. Number 4, 2 times 3x, which you could write as 2 times 3x. 2 little dot is sometimes used to indicate multiply, 2 times 3x, or 2 brackets 3x. They all mean 2 times 3x. What's the answer? Just jot down the answer. Number 5. I don't want the answer to this question is not 1/3 of 48. If we look at the question, 1/3 of 48 is the same as 48 divided by what? What's the missing number there? Is that better? If I close it, it all goes weird. So, number 6. There's a formula that hopefully some of you at least are familiar with. If I equals 12 amps and R equals 24 ohms, find V. Number 7. Fractions is something that does come up. It's strange that it doesn't come up in pure form, like you always ask questions like this in engineering. No, that doesn't happen, but knowledge of fractions is crucial when it comes to manipulating algebra, and so I'll make no excuses for that. What's 1/2 plus 3/4? Just jot down the answer. Number 8. Estimation is a useful skill for an engineer. Come up with rough values for things. Estimate the mass of a small car like a Mini. You choose the unit you're going to measure it in. Estimate is another word for guess, but engineers guess it in an educated way. Come up with a reasonable figure. Number 9. Which is the odd one out? 3 of these give the same answer. One of them is different. Which is the odd one out? And the last question, confidence question really, how many questions do you think you got right out of the previous 9? So it's out of 9 actually, not out of 10. How many do you reckon you got right? Okay. Now let's look at them. So I'm not going to take them in and mark them. We're going to you're going to self-mark them now. We're going to go through them. So number 1, and I'll sort of just pick on people at random. Where's the register gone, please? Right, thanks. Can you pass it forward? Thanks. So Charlotte, just at random. Actually, no, not you, Charlotte, because that was a bit unfair, wasn't it? Straight in there. Buster, next to you. Okay. 10% of 48 metres? 4.8 metres. What did you do to arrive at that, Buster? You just knew it, did you? Well, what did you do? Divide it by 10, right. So 10% is the same as divide by 10. Did everybody know that? What is 10%? What does it mean? A tenth or 10 out of 100? Yeah, somebody said. It literally means 10 hundredths, which is a tenth. How do you get a tenth? Divide by 10. 1/10 is the same as divide by 10. It means divide by 10, doesn't it? To find a tenth of something, I divide by 10. How do you divide by 10? So what did you do, Buster? Right, okay. Yep. Move the decimal point is what I thought you might say. Yeah, move the decimal point. Where is the decimal point now? Sorry, what's your name?
Reese.
Reese. Where is it now?
After the 8.
Right, so if there was no decimal point in a number, it's always on the far right-hand side. Always. So there it is. I'm going to move it back 1. Dividing by 10 means to move the decimal place back 1 place, doesn't it? You all knew that, didn't you? So that's very useful to find 10% of something. I just shift the decimal point back 1 place, and that's very helpful if I want to find 5%, if I want to find 20%, if I want to find 25%, if I want to find 30%, and so on. Knowing how to quickly find 10% really helps. If I was on an engineering site and I just employed you, and I asked you, what 20% of something is, and you reached for your calculator, I'd be thinking, his math's not very good, okay? And so it's all about confidence, and that's what I'm trying to build with these things. Ben Wallace. Where are you, Ben?
£6.15.
£6.15. How did you arrive at that?
Half £8.20, which is 50%.
Right, so half is 410, yeah.
And half that again.
Half of that is,
25%.
yeah.
Add them both up.
Add them together to get £6.15. Yeah. Why did you add them together?
That's 50% plus 25%.
Right, okay. 50% plus 25%. A quarter is 25%. So yeah, so you're finding 1/4, and that's what I would always do to find a quarter, half and half again. And once you've got 1/4, you want 3/4, so you want 3 of them, don't you? Yeah, anybody do it differently? Which would be equally valid, but that sort of little thing to find 3/4 of something is... Yeah, so how did you divide by 4? What, 4s into 8 goes 2, 4s into 20? Yeah, okay. That tended to work on that one because that's quite straightforward, but not necessarily quite so straightforward on something like £3.42 or something. Half of that, and then half it again, probably an easier way to go about doing it. Yeah. And of course, you all realise, I hope, from that, and if you've got this right, that means to me that you do realise it. The obvious thing is that means what you've divided, what you've got, how many bits of that you've divided it into. I want to divide that by 4. I want to cut it into 4 bits. And then this number's telling me how many of them I want, isn't it? Okay. Please add anything to this as we're going through. Anything else you do, or any comments you want to make, or anything you don't understand. Lewis, yeah. What did you get for that? 5x. Why? Right, okay. This means I've got 2 lots of x. That's the same as that. X plus x means 2 lots of x. What's 3 lots of x? So what does 3x means? It means x plus x plus x. 3 lots of x. So altogether, of course, I've got 5 lots of x. What's x, Lewis? An unknown what? An unknown, well, yeah, it is an unknown, but it's not an unknown as in, just demonstrate how good I am at drawing things, bolt. It's not an unknown bolt or nut, it's a number. It's an integer, not necessarily an integer, but a number. It's a number, yeah. So what is x? A number. Always, it always stands for a number. We just don't know what that number is, right, Lewis? And so that means I've got 2 lots of some unknown number, 3 lots of some unknown number. So add them together, I've got 5 lots of that unknown number. So if I know that 2x plus 3x equals 30, I could go, I've got an equation there, and I could find out what that unknown number was. Because I would say, 2x plus 3x is 5x, so 5 lots of x is 30, and then I can think about, so what must that unknown number be? And I can solve the equation, okay? And that's the sort of thing we will be doing. Comments? Jordan Southgate, where are you, Jordan? Jordan. 6x. So why, Jordan? Right, so that means, all of these mean 3 lots of x is that, but then I've got 2 of them, so it's plus another 3 lots of x is 6x. Yeah. 2 lots of 3x. Which is the best way to write this? The bottom one, yeah, is the best way. That is sometimes used, so don't let that confuse, that's why I put that in. That we wouldn't use. Why not? Yeah, it's confusing. The time symbol looks like an X. Avoid that in algebra, okay? That's the way we try and write 2 lots of 3x, 2 times 3x. Charlotte? Third of 48 is the same as 48 divided by 3, right. We sort of talked about that already, haven't we? A third of something is the same as x divided by 3. That's why I did this. Look at that. Algebraically, that's that statement written algebraically. A third of an unknown number, x, is the same as taking that unknown number and dividing it by 3. This means divide by 3, x divided by 3, x over 3. They're the same thing. So really I should put 3 lines here to mean equivalent to. A third of x is equivalent to x divided by 3. They are the same thing. And it's worth pointing out because later on you might be doing things that maybe are a bit more complicated and noticing that x plus 4 squared, for example, over 2 that might come in some expression, and it might be worth realizing that actually that's the same as x plus 4 squared, and in front a fraction. What fraction am I going to put in front? Aha. That is the same as that. And that's what that's saying, really. And that's not immediately obvious sometimes when you're in the middle of an algebraic problem. Anybody recognise that formula then? Yeah, I'm looking for someone that last year. Who was it I was just talking to that did a couple of weeks last year? Yeah. Was it you? No. Somebody got. It was you, wasn't it? Of course it was. You know that, don't you? Yeah. Name of this law. Ohm's law. Yeah. So, what does it mean? How do I calculate the voltage? Right, times. No symbol between these letters means multiply. Remember, we're trying to avoid that multiplication symbol. So what do we do? Well, we assume that if there is no symbol, it means multiply. So IR means I times R. So V equals 12 times 24. Does it matter whether or not I write V equals IR or V equals RI? No, because the multiplication doesn't matter which way around you do it. 12 times 24 without a calculator. How do you do it without a calculator? No, that's why I saw you fiddling around, that's why I asked you. But how would you do it on without a calculator? Anyone? 10 times 24 is? And now what have we got to do? Ten times 24 is 240, so I now need to, which is 48, and now what do I do? Right, that's how you could have done it, okay? Don't automatically reach for the calculator. In these drills, unless I specifically say, no calculators please, 288 volts, yeah. Then you can practice those skills, okay? What's the subject of that formula? B, I heard someone say yes. Subject means the formula is set up so that it reads one of the letters equals something. V is the subject of that formula. If I wanted I to be the subject of that formula, I'd have to rearrange it, and we will be spending some time doing that sort of thing, okay? So often the formula is in the right form. It's what you want to find is the subject. That's okay. But actually, particularly with this one, you could just as easily want to find the current or the resistance. So you might well need to rearrange the formula to make I or R the subject. Oh, by the way, 288, did you say volts? Right, okay. Don't forget the unit, but yeah. Okay. Half plus 3/4, side bench. 2/3, just find a 6. What did you do? Okay. Not right, unfortunately, okay. We're just going through some little drill questions we've been doing, so you just have to catch up, okay? Can you pass this? No, I need that. Remind me at the end, you've got to put your name on this register. Someone else feeling confident about this one. 1 1/4. Anyone say anything different? Yeah. Could you have written this a different way? 5/4. If you are not feeling confident about this, there's sections in here, but not much on fractions, because this is starting off assuming a certain level of knowledge. But the library downstairs, the LRC Learning Resource Centre, is crammed with maths texts with practice on GCSE on fractions. You need to get comfortable with it if you're not, okay? Why is it this? Why is it this? What did you do to come up with that?
I popped into
Into quarters? Yeah.
adding
Yeah. That's the key. Sorry, what's your name? Scott. That's the key. To be able to add these must be the same. Remember that number tells us how many we've got. I've got 2 quarters plus another 3 quarters makes 5 quarters. 5 quarters is a whole one because 4 quarters make a whole one, plus 1 more, so 1 1/4. Okay? If I wanted to add £2 plus $3, I couldn't do it. I'd have to convert the pounds to dollars or the dollars to pounds, and that's exactly what I'm doing here. I'm making the thing that I'm adding the same. You can only add things that are the same. I can add x's because I might not know what x is, but what I do know is that whatever it is, it's the same, so I can add them. Yeah, everybody happy with that? So if you want to add fractions, Scott, the key is you make, and the posh name is denominator, the number underneath, you've got to make the denominator the same and then you can add them. Tommy, where are you? What do you reckon? 1.2 tons? Anyone else? Half of that? So what's half of that? 650 kilos? 850? I should have stated on there, of course, the new money or the old money. The new mini is just over the ton. So did you mean the new mini? Yeah. And the old mini is about 800 or 900 kilograms. So did you mean the old mini? Yeah, the old one. So, but of course, remember this: 1,000 kilograms is a ton, so that's about 1,200 kilograms. So, yeah. Okay. Not bad estimates, depending on for any of them actually. Okay. What we're after is not 100 kilograms, not 10 tons. An order of magnitude idea of what something should be is useful for an engineer. If you do a big calculation, say as part of this calculation you want to find the mass of a car, and you do the calculation and the answer comes out to be 12 tons, hopefully a little bell would go off in your head and you think, actually that looks a bit big, I better just check that calculation. Or it comes out to be 20 kilograms. No, that can't be right, surely. Okay, do it again. Having a feel for what you expect the answer to come out to be is useful. Number 9. Aaron. Where are you, Aaron? Oh, 2 Aarons. That Aaron over there. Which is the odd one out?
I went to C.
C?
But I was working around and then you changed the question.
Right. Okay. Anyone disagree?
Which is what?
You put A?
Well, now I'm saying C is the same as A. I put B.
Oh, okay, you put B. Anyone have anything else? No? Anybody? Did you put C?
No.
Yeah? It is B. Yeah, B is the right answer, so well done. Who would have said B? Why? Reese, isn't it?
Yeah, well, all the others is just a form of dividing it by 3.
Yeah.
D times it by 30, it's the same as times it is divided by 3.
Yeah, everybody, can anyone hear Reese? Yeah. Timesing by a third is the same as dividing by 3. We've said that already, haven't we? Okay, so that's equivalent to that. Go on, Reese.
It's A and C. I didn't even work
Yeah.
out C.
Yeah.
Just did it out.
2/3 means 2 divided by 3, so it must be this one. What's wrong with it though? What should it be? One sec, Mike. Yeah, okay. What should it be? Change them round. It should be 3's into 2. If you want to work out what 2/3 is as a decimal, you have to do, on the calculator, 2 divided by 3. And it tells you 0.666666666. If I wanted to work that out on a piece of paper, because I didn't have a calculator, I'd have to work out how many 3's there are in 2, not how many 2's are there in 3. And so that's the odd one out. The last question. Now you can answer that, can't you? And then just put the total out of 9 on it, please. Make it nice and clear for me so I can see it. And I just wanted to have a quick scan through and see where you went wrong on some of them, maybe. And then make sure your name's on it, and then just pass them forward, please, while Mr. Betts. Do you want to speak?
I've got to go through everything again because Stan's changed one person.
Right.
So
you want that
sorry
list?
about your lesson, Mark.
That's all right.
But I need to mark them off as well.
Yeah.
I've got to do the groupings with Louise.
Right. So you
that
need
needs
that.
that needs to disappear.
Okay. Right. I'll leave. Do you want to just talk to us a little while
the
then?
floor just for a minute,
Yeah.
please. Yeah.
Hang on. Just need to pause this.